Hello everyone. So we are continuing with the policy evaluation week 6. So in the last class we discussed about the randomized control trial, which is also known as the true experiment. Okay, and today we'll be taking some examples of this RCTs. Okay, along with we'll be introducing some quasi-experimental design. Okay, and we are left with the other two topics that needs to be discussed is program evaluation, that what governments usually do vis-a-vis what governments can do. Okay, so let's discuss some of the examples that we can consider under this randomized control trial. So let's take a question. So the problem is that suppose say we are considering this problem of job and training program, right? And for this job training program, which is quite a new program right now in this context, it has some characteristics, right, for the targeted population for which it is going to be implemented. Okay, so here the average treatment effect under the ideal condition, that is 100% compliance is there. Okay, 100% compliance with the random assignment is found here, and given this 100% compliance, that those who are assigned with the treatment group, so these participants are actually participating in this job training program. Okay, so that is the reason it is known as 100% compliance. Okay, so taking this 100% compliance, now we are considering that job training program, and we need to identify that what is the impact of this job training program on the population or on the participants, those who are participating. Okay, so the characteristics of the study population under consideration is that if the population are not getting any job training, then those population or those individuals in that population will be just able to earn 80 rupees per day, right? And the scenario is that if these individuals under this population, if they participate, then they will be getting some benefit. Again, the individual benefits also differ, right? So that means the program would be more effective to some individuals and less effective to some individuals. So what are the details of those? So for half the population, the income increases by 40 rupees. So if individuals do participate, for half of the population, the income increases by 40%, and for the other half who participates in this program, their income increases by just 20 rupees. And those who do not participate, then their income is as it is, that is 80 rupees per day. Okay, so given this information, now we need to identify that whether the job training program is effective or not, or in other word you can say what is the impact of this job training program on the population that we are considering. Okay, so now check the details. So here we can find that there is a treatment group. Okay, so what is that treatment group? Where the individuals are getting benefited. Okay, so if they are participating, their income increases by 40 rupees, right, for half of the population, and for other half of the population who have participated, so their income increases by 20 rupees. Okay, so that means this is the treatment group. So for treatment group, right, what would be the daily income right now? Because if they are not going to participate, then initially their income is 80 rupees, and if they participate, then their income increases by 40 rupees, and for other half the income increases by 20 rupees, right? So that means it is 120 and this is 100 rupees. Okay, but we have to find out what is the observed daily income for the entire group. This half and this half makes the full group of our treatment group, right? So since those population who are under this treatment group, right, for half of them the income increases by 40 rupees and the other half income increases by the 20 rupees. So that is the reason we can, in order to find out what is for the entire group, what is the daily income that we can observe is 0.5, that is half, right, multiplied by 120, this is 120, again the rest half, that is 0.5 multiplied by this 100 rupees. So for the entire treatment group, the object daily income would be 110, right? And what would be the impact of this program for the control group? Control group is that group where the job training program is not implemented. That means the individuals in this group do not participate in this job training program. So, if they do not participate, then their original income remains as it is, that is 80 rupees. So, this is consistent to this Y0 for everyone those who are under this control group, right. So, now we can find out what is the impact of this particular job training program. Okay. So, that we can find out by calculating what is known as the average treatment effect, right. So, what would be the average treatment effect? We have already discussed in the last class that how to find out. So, here what is the impact on the treatment group? This is 110. What is the impact on the control group? So, this is as it is, right. This is just a comparison group. So, 80 rupees. So, the difference between these two is your average treatment group, that is 30 rupees. Okay. So, let us interpret or let us understand some of the features or some insight from these calculations. Okay. So, since here we assume that all those who are assigned or all those individuals who are assigned in the treatment group, they would be fully participating in the treatment, right. So, that means there is a perfect compliance or 100% compliance. So, because there is 100% compliance, the difference in the mean outcomes between the two groups, right, mean outcomes between the two groups provides an unbiased estimate of what? Average program impact for the entire population, and that impact is your 30 rupees. Okay. And let us suppose say here, if you are defining the other concept that we discussed in the previous class, that is average treatment effect on the treated. Okay. So, if this average treatment effect on the treated is determined by those participants or those persons who actually participates, then in this scenario, this average treatment on treated would be equal to average treatment effect. Okay. So, what we are finding here in this example, since there is 100% compliance, right. So, that means we are saying there is no one is forced to participate. That means this is a case of not forced 100% compliance. Okay. But if we consider or if we define this average treatment on treated as those who would participate if they would be given a chance, right. So, suppose say out of these individuals who are participating right now, right. So, this is 100%, it may be because of the compulsions, right. So, that is the reason they are participating, but it may also happen that if they are given a choice factor, that it is up to you that you may participate in this job training program or you may not participate in the job training program, then the average treatment effect on the treated can be defined in other ways, right. So, how to define? So, you can say that if average treatment effect on the treated we are defined like who would participate if they are given a chance. Okay. So, in that case, the average treatment effect could not be estimated in this particular case because the data does not show which specific individuals, those who are gaining, right, by how much, high gaining individuals or low gaining individuals, they would have self-selected into the program, right. So, in this scenario, this particular scenario that we are considering here, it also raises an ethical question of whether forcing participation to achieve the 100% compliance for an evaluation should be acceptable or not, right. Now, let us consider a situation in which some individuals assigned to the treatment group choose not to participate. So, that means we are not compulsorily assigning these members in the treatment group to participate, rather we are giving them options or they are given the choice that if they at all are interested, they may participate. Okay. So, in this situation, particularly in this situation, right, what is happening, that how to calculate this average treatment effect on treated, because when some individuals assigned to the treatment group, but they are choosing not to participate, in this case how to how to find out what is the average treatment effect on the treated. Okay, because here we consider that when there is 100% compliance, then average treatment effect is your average treatment effect on the treated, right? But here we are finding that, or the condition is different, that here it is not the case of 100% compliance, rather it is given a choice. Those who are assigned to the treatment group, they may or they may not participate. So, in this case, how to calculate this average treatment effect on the treated? Okay. So, we are continuing with our same example of our job training program, where individuals earns 80 rupees per day without participating in the training. Okay, and completion of the training program has different impacts to different individuals, right? So, in the treatment group itself, the impact are different, and the impact can be divided into two groups, that some individuals are categorized as high gain groups. So, that means after completing the training program, their income increases by 40 rupees. So, their income would be 120 now, because 80 is before the training program, and now 40 is 120. So, likewise the second group, for the second group under the intervention group, we can find the increased income, that is to 100 rupees. After the completion of the training, their income would be increasing to 100 rupees. Okay, and again each group makes 50% of the study population. Okay, so this is 50%, this is also 50%. Okay, and since we are assuming here is that participation is voluntary, it is not compulsory. Okay, so that means 100% compliance would not be there. So, since participation is voluntary for those assigned to the treatment group, right, and people select into this program based on their choice, and choice is based on their gains, anticipated gains. So, the other details are available, that is 75% of the high gain groups, they chose to participate. Okay, and 25% of the low gain group, they choose to participate, right? And of course 0% of the control group is able to participate. That means from the control group, no individual participates. Okay, so given this information, now we can find out what is the overall participation rate. Okay, so what would be the overall participation rate, we can find out. So, this is from the high gain group, right? What is the participation? That 75%. Okay, and this 75% constitute half of the study, half of the population study. So, this is half multiplied by 0.75 plus this is again half, this is also half of the populations under this intervention group. So, again the 25%, that is 0.25, right. So, this is 50%. So, the overall participation rate, right, in this situation, when they are given a chance to actually participate, even though they are under this intervention group, so their participation rate is 50% for those who are assigned to the treatment group. Okay, now we can calculate the average treatment effect on the treated. Okay, and here we can find at least two ways to calculate the average treatment effect on treated in this particular example. The first method that we can consider here, that when we have complete population knowledge, right. So, that means all the details about the populations are given. Then if we know exactly who participated, who calculated, and then we can calculate the weighted average gains for those individuals. Okay. So, we know that the treated group consists of some persons which are getting high gain, right. So, what is the percentage of those persons? It is 75%, right, 75%. Okay. So, they are getting 40% increased income, and 25% people are from the low gainers. So, their income increases by 20 rupees. Okay. So, now we can find out the average treatment effect on the treated. So, how to find out? So, this is for high gainers. So, 75%, right, and their income increases by 40 rupees. So, 7.75 multiplied by 40, then 25 percent from the low gainers, that is 0.25 multiplied by the gain, that is 20 rupees. Okay. So, this is 35. So, the average treatment effect on the treated is now 35. Okay. So, this is the first method. When we have complete information about the population, we can find out this average treatment effect in this way. So, we can also find out this average treatment effect by using the formula that we have already discussed in the previous classes. Okay. So, in a real evaluation, we can find the mean outcomes, that is denoted by y, right, and the participation here is denoted by p. So, we can find out this average treatment effect on the treated, okay, by following this formula. Okay. Now, you can see this is our numerator, right. So, this is also known as the ITT effect. Okay. So, the difference in mean outcomes, that is particularly the difference in mean outcomes between those offered the programs, right, those who are offered the programs and those who are not offered the programs. Okay. Those who are offered with the program and those who are not offered with the program. Okay. So, we are taking into account the mean outcome, difference in mean outcomes. Okay. So, by just putting this, the information that we have been provided, we can find that this is what those persons, right, who have not participated, right, and what is their mean outcomes. So, of course, the mean outcomes would be 80 rupees only, right, and here those who have participated, right, and they are considered the high beneficiaries and low beneficiaries, and their percentage of participations are also given. So, we can find out by differentiating. So, this is 17.5, right, just putting all the details. So, we are finding this is 17.5, right, and what is our denominator? Denominator is our participation, right. So, participation is half, that is 0.5. So, what is the average treatment on the average treatment effect on the treated? That is this 17.5 divided by 0.5 equal to 35. So, in both the methods, we are finding that the effect is ATT is found to be 35. Okay. So, that means the average treatment effect on the treated is 35. That means the income increases by 35 rupees. Okay. So, now we can move to discuss about the second part of our impact evaluation methods. Okay. I told you that the impact evaluations can be of two types. The first one is experimental methods, okay, and the second one is non-experimental method, which is also known as quasi-experimental methods. Okay. So, this experimental methods we have already discussed with examples also right now. Right now, let us discuss what is this non-experimental method, or which is also known as quasi-experimental methods. Okay. So, basically this quasi-experimental methods or non-experimental methods are used to evaluate the policy or program impacts when there is no scope of randomizing the assignment. Okay. So, when it is not feasible to randomly assign the subject, then in those cases we cannot actually apply the true experiment or randomized control trial experiment. So, in those cases we can apply the non-experimental methods or quasi-experimental methods. Okay. So, now remember, in a true experiment, that is under your RCT, so the researcher or policy analyst, so they randomly assign the subjects into two broad groups, that is control group and the treatment group. Okay. But here in case of quasi-experimental methods, so this provision is not feasible, or this cannot be done. This is not possible, or this is not feasible, okay, because of many reasons. Okay. But however, while following this non-experimental methods, so they attempt to provide the mimic randomization. Okay. So, what is this mimic randomization? That means it is a kind of shadow randomization, it is not a true randomization, okay, by applying some statistical models to the data that we have collected from the survey, and it allows to construct the convincing comparison group, or which we say that the counterfactual group, counterfactual data can be found out, okay, through the statistical models from the program participants. So each of these quasi-experimental methods, right, they have certain assumptions, right, for addressing the problems that are because of the selection bias. Okay. So based on this understanding, now let's discuss what is natural experiments, which are also a part of our non-experimental methods. Okay. So this is our natural experiments. So what is this natural experiments? So generally these natural experiments occur when in a real world situation we find or we create a treatment group and the control group with the features, but it happens by accident. So that means the researcher or the policy analyst never assigns the subjects into these two groups randomly, rather naturally in the real world system accidentally these two groups are created. Okay. And because the true randomized control trials are really very expensive and sometimes it is unethical, sometimes it is not practical, right, to execute at the government level for finding out the impact of a policy, impact of a program. So policymakers generally rely on these natural occurrences to isolate the effect of the treatment from the control. Okay. So we can give an example that how this one natural experiment would be different from our randomized control trial. So as I have already highlighted that although in natural experiments we can naturally create or accidentally create these two groups, that is our treatment group and the control group, right, but it doesn't happen randomly, or randomization of assignments is not possible by the researcher itself. Okay. So that means we can give an example that what could be the difference between the natural experiments and the randomized control trials. Okay, we can give an example that would be more easy to understand. Let's say that the families are interested to send their children to private school which are really costly, right, and in order to encourage quality school education, now let's say that there is a provision of 500 vouchers to be provided to the applicants. Okay, and those who would be receiving this 500 vouchers, so they will be getting admission to the private schools. Okay. So now what happens that for receiving this 500 vouchers, right, and these families, right, they are really interested to send their children to private schools. So 1000 households or families, they applied for this, for getting these vouchers, but distribution of this voucher is by chance, that is by random. Okay, it is not deliberate. Okay. So in this case what is happening, how many would be getting admission into the private schools? So those who would be receiving the 500 vouchers, right, but what is the original applications? The original applications are 1000 applicants are there who are interested to send their children to private schools, right. So here we can find that when 500 vouchers would be distributed through lottery or some other randomization processes, so that means they would be getting a better education systems or better education facilities through this private education systems. Okay. So this is what the example gives us. So and but the rest 500 would not be eligible to get into this particular education system. So they will not be given this education system. Now those who would be participating or possessing this 500 vouchers, so they would be known as the treatment group, right, and other 500 households, those who have already applied but could not get the vouchers, right, but since all these applicants are there, so that means they are really interested or equally interested to send their children, right. So that means the family characteristics would be similar. Okay. So that is the reason we can find the similarity in the treatment group here for this 500 households, and here those who have not considered under this treatment, but they would be also displaying similar characteristics. Okay. So that is the difference between the natural experiments and the randomized control trials, that although we are finding these two groups which are quite similar, but the difference is that they are not randomly assigned. Okay. So when we are finding the groups to be of similar nature, but they are not, the participants are not randomly assigned, so in that case we are saying that randomly assigned by the researcher itself. So that is the case of our natural experiment. But in case of RCT, that randomization happens for creating the similarity in two groups by the researchers himself. So that becomes the part of our RCT. Okay. So yes. Okay. So now we can discuss the second non-experimental method. So that is known as the propensity score matching, PSM method. So what is this PSM or propensity score matching? Again, as I told you, that this is also a non-experimental method that are largely used to estimate the impact of a particular policy program by constructing a comparison group, right? And this comparison group is constructed through the statistical models only, based on the probability of participating in a treatment, right, given a set of observed characteristics. Okay. So what is the broad objectives of this PSM? Again, the objective of the PSM is to create what you can say similar group, right, or counterfactual group which could be similar to the treatment group. Okay. So now we can say that when we are applying this PSM, then PSM tries to mimic the randomization process, and when a randomized control trial is not possible, right, so that is the reason researchers try to develop a counterfactual group that would be quite similar to the treatment group, right, in many aspects or in almost all the aspects, right, in every possible terms, okay, from the observed data. Okay. So that is what is known as the propensity score matching method. So basically a counterfactual group is constructed by the help of the statistical comparison group. Okay. By the help of statistical models, we construct a counterfactual group which is known as the comparison group. So that happens in the propensity score matching method. So for this method, there are certain assumptions. So what is the assumption for this PSM? That this PSM assumes that there would be confoundedness, right? So we have already discussed what is confoundedness, right? So that is also a problem, right, in our policy evaluation or program evaluation. But here the condition is that there would be no confoundedness. So that means the unobserved factors do not affect the program participation, right? So because we already discussed that there are some observed factors and there are some unobserved factors. So here the unobserved factors do not affect the program participation. That is what is known as the unconfoundedness. But if the unobserved factors affects the program participation, it leads to biasness. So that is what is known as the confoundedness. Okay. So another assumptions of PSM is of the common support or overlapping. We can realize the overlapping region as well. So for this common support or overlapping, to identify this, this PSM requires a sizable overlap in the propensity score, right, and propensity score ranges between 0 to 1, right. So this propensity scores between the participant and the non-participant sample. So we have to identify that what is the propensity score for each of the individuals, right, between the participant and non-participant samples. Okay. So this PSM also ensure that each treated observation has a comparison observations. So that means it follows the nearby in the propensity score and distributions. Okay. So that means the observations that fall outside the nearby propensity score and distributions, so they are dropped from our analysis. Okay, so suppose say the propensity score here in the treatment group is 0.6 and here it is somewhere 0.59. So then they can be matched. But if somewhere here we are finding 0.9 and there is like 0.4 here, so we have to drop this and we have to drop this. Okay. So now let's understand, given this basics of PSM, now we can understand what are the implementation process for our PSM. Okay. So we can apply this PSM, right, in 3-step processes. Okay. The first one is we have to estimate a model of participation, right, and for that we pool the participants and the non-participants, and by following basically the limited dependent models like probit model or logit model, we try to estimate the probability of participation based on the observed data, right. So when we try to estimate the probability of participation based on the observed data, so it generates what is known as the propensity score, right, a single propensity score for each individual. Just like I told you that it could be between 0 to 1. So for individual score, let's say it is 0.6, 0.8, 0.7 and likewise. Okay. Okay. So the second, once this is done, that means we estimate a model of participation by using this probit and logit model, right, and estimate and generate the propensity score. Okay. So once this is done, then the second step is defining the common support and balancing test. Okay. So we have already defined what is common support, right. So here basically the analyst or evaluators identify the region where the propensity score overlaps. Okay. So if this is 0.5 from the participation group and non-participation group it is 0.49, so it overlaps. Okay, or it is 0.5 and it is also 0.5, so it overlaps. So the evaluators try to identify the regions where the propensity scores overlap and perform balancing test. Okay. So basically these tests check whether within the different blocks that I told you here, within the different blocks of the propensity score distribution, the mean of the each observed characteristics, right, each observed characteristics is same for both the participants and non-participants. Okay. So that is again another important step for our PSM implementation. Okay. Right. So once we are done, then we have to match the participants to the non-participants. Okay. For matching the participants to non-participants, we use various algorithms, right, to pair the individuals based on the PSMs, that is propensity scores. Okay. So some of the algorithms that we mentioned here, that these are some important algorithms that we can use for this matching processes. So the first could be the nearest neighbor matching. That means here each participant is matched to the non-participants with the closer propensity score. So that is what I say, if it is from the treatment group, right, we are finding this is 0.5 and here 0.51, then this is what is known as the closest propensity score, they are matched. Okay. And the second one is the stratification, that is interval matching. So here the common support is partitioned into the blocks, and then the program impact is calculated based on the weighted average of the mean differences in each of the blocks. Okay. And the next one is radius matching, where matches are made only within the specific tolerance limit or distance of propensity score, just to avoid the poor matches, and the poor matches are generally dropped, right. And last one is the kernel and local linear matching. So again these are the non-parametric methods that are used as the weighted average of all non-participants in the common support to construct the counterfactual for each of the participants. Okay. So we are done with this, that what is this propensity score matching, and also we discussed about what is known as the natural experiments as a part of our non-experimental methods, right. So we, in the next class, we will be discussing the other quasi-experimental methods like double difference or difference in difference and other methods. Okay. Thank you.